Hey chemistry, let's review before our chapter 11 test. So I've outlined your test here. In fact, I put this whole worksheet attached to this video in Google Classroom. So the first thing you'll see on your test is some matching vocabulary, as always, on the first page. And then something different I put on this test is a little bit of a fill in a blank vocabulary. So you really got to know those vocab terms well for this chapter and make sure you kind of know how to use them in a sentence. But you'll just be fitting the vocab words into blanks, and the word list will be given to you. Part C on the second page of your test is multiple choice. So as long as you've been watching these videos all along and reading your textbook before you do your homework problems, you should have no problem on that multiple choice. Part D is your calculation. So this is definitely what we're going to be spending the bulk of our time on this video. Here's the first problem. It says balance, then determine how many moles of O2 are produced from 10 moles of KClO3. So just kind of take note here in this problem. It says how many moles, and you're given moles. So on our moleville chart, we're going from moles to moles. And this is true of a lot of problems in stoichiometry where you may not start with grams. You may just start in moleville and just have to provide one fraction to get to the other side of the equation from particle A to particle B. So push pause, go ahead and try that problem out. I'll try it out too, and we'll see if our answers match. So push pause now. Welcome back. This is how I balanced my equation. I saw that there were 2 oxygens on the right and 3 on the left. That's one of those odd even problems, so sometimes just switching the numbers really works to balance it. Put your 3 over here and your 2 over here, and therefore you have 6 oxygens on each side. Hey, that worked. Then you notice though that you messed with some other elements, 2 Ks and 2 Cls, so putting a 2 there will fix that right up. Remember, when you're balancing, to not mess with coefficients, not mess with subscripts, but only work with the coefficients. All right, you're given 10 moles, so put that there. Moles of KClO3 on the top. You guessed it, moles of KClO3 on the bottom. And we're trying to get to moles of O2. So we can write our mole ratio here to help us out. Our balanced equation tells us to put a 2 here and a 3 here. Then we can stop this problem. We don't have to go to grams because it asks for how many moles of O2, and that's the unit that we are left with. So perfect. That cancels, and we have the right unit left to give us 15 moles of O2. Make sure you multiply by this 3 and then divide by the 2 in your calculator. All right, try out this next problem. You're going to want to push pause on this one to copy this down, balance it, and then go from grams to grams. Push pause, try it out. So to balance this equation, which is really important so you get the mole ratios right, is to simply put a 2 here. You'll notice you have 2 Cls, 2 H2s, so putting a 2 in front of our hydrochloric acid will balance out this equation. Now notice our mole ratio in this answer was 1 to 1, but if I had given you HCl and asked for grams of NGCl, then you would need to involve a 2. So you never know what you're going to see on your test, so make sure you balance well before you get started on the stoichiometry. I was given 40 grams of magnesium on the top, grams of magnesium on the bottom. I go to moles. Moles on the top, moles on the bottom. I'm at my mole ratio, moles of MgCl2. And moles on the top, moles on the bottom. Notice I'm keeping the same compound as well. And then I'm going to grams to finish out this problem. So my units cancel every single time. I hope you're getting the hang of this by now in this section. And multiply across the top to divide out this number, and you get 157 with proper sig figs grams of MgCl2. So what we did in this problem is we went from grams of product A to grams of product B. On your mole map, that looks like grams to grams. Use your periodic table and a 1 mole for your molar mass. Then use your mole ratio to switch from A to B. Then use 1 mole and your molar mass from your periodic table to end up with grams per mole. And then your answer is in grams of particle B. So you can see how this mole map starts and ends in various places. This one happened to be a problem where we were going all the way across from grams to grams. But sometimes you don't start with grams. Sometimes you start with moles, or sometimes you end with moles. So try out number 3, push pause, and we'll check our work. So you write out the equation. Don't forget that this needs to be a single replacement reaction because zinc will trump here on our activity table and take over the bond. So H2, don't forget to Hunkelbrief that, that's diatomic. And then you balance. Since there are 2 H's and 2 Cl's, we need a 2 here to balance this equation overall. All right, 5 moles is what we started with. Moles on the top, moles of zinc on the bottom, and our molar ratio is 1 to 2 in this case, which is why it's really important to balance well. Moles of HCl on the top, moles of HCl on the bottom. Of course, we use a 1 this time because we're doing a molar mass, which is only 1 mole of something. Tally it up on your periodic table. H in a Cl is 36.461 grams. And we end up with our final answer of 365 grams of HCl. So we started with moles here, and we use a molar ratio to cross the border and get to grams at the end. So what we did here in this problem is we started here with moles and used the molar ratio to cross the border, and then used 1 mole for our molar mass to get to the final answer of grams. So the idea here is the same in 2 and 3. You start with self, what am I given? Make that your first number in the problem, and then think, okay, grams of MgCl on top, grams of MgCl on the bottom, and then get going that way. 4 says calculate the percent yield. Remember, percent yield is simply the actual yield, so 4.9 grams, over the theoretical yield, or 5.2 grams. Divide that in your calculator. Oops, I gotta multiply by 100. So don't get a question like this on the test wrong. This is like your easiest points right here. Make sure you know how to do these. 2 sig figs, so I'm going to round off here in my calculator to 94% yield. Now remember, a reaction is never perfect. Usually you get less yield than what you theoretically expect, and that's just because of, nobody's perfect with scraping everything out of the bowl, or all the reaction proceeding forward, for example. So that's a pretty high percent yield, though. 94% is a good day for a chemist. So moving on to number 5, this one I gave you the balanced equation already for magnesium and hydrochloric acid. Notice this is the same one from number 2, but this time I'm going to ask you, with 29.5 grams of magnesium chloride produced, we're going to calculate theoretical and percent yield. So we have the number for how much was produced. That's going to be the actual yield, but we don't have the theoretical yield yet. So we need to calculate that with stoichiometry first. Push pause, try that out. And so here we have the answer. 10 grams of magnesium is what we start with. Don't make the mistake of starting with the 29.5 because that's the number we're going to use at the end when we compare our outcome to the actual yield. We were given 10 grams in an experiment, 10 grams of magnesium. So start there, grams of magnesium on the top, grams of magnesium on the bottom. We have our molar mass, moles of magnesium on the top, moles of magnesium on the bottom. We're going to magnesium chloride, so put that on the top. This is our molar ratio. We take that from the coefficients in the balanced chemical equation. It's a 1 to 1 in this situation. Moles of magnesium chloride on the top, moles of magnesium chloride on the bottom, molar mass, and we tally that up from our periodic table. Go ahead and multiply across the top, divide out this number. I'm going to show you real quick what that looked like on my calculator, just so you can kind of see how I did this. I took the number 10 and multiplied by that molar mass. I took my answer and divided out what was on the bottom fraction here. So that's how I got my 39.2 grams of magnesium chloride. But this question also asked us to calculate the percent yield. So I took that number and put it in my denominator here. The actual yield was 29.5, so not quite as good as the last problem. 29.5 grams recovered when we were expecting 39.2. Divide these numbers out, multiply by 100, and you get 75.3% yield with proper sig fix. So I hope you got that problem right. This next one deals with our raisin chocolate chip cookie again. You will see one of these problems on your test where you have to think about what limits. If I have 12 chocolate chips and per cookie and I have 144 on hand, let's try this out. That gives us 12 cookies just based on chocolate chips. If I have 104 raisins on hand for a recipe and I need 8 per cookie, then I can get 13 cookies according to raisins. But one of these is going to limit us, and what limits us here is the lower number. I can only make 12 cookies according to how many chocolate chips I have, so I can't actually make 13 because I would run out of chocolate chips at that point if I tried for 13. So I'm only going to make 12 cookies. So this problem says, how many cookies can I make? The answer is 12 cookies, and it says, if you need to explain this, you're going to say you can only make 12 cookies because you do not have enough chocolate chips for 13 cookies. And if it asks you to use the word limiting reagent, you can say that chocolate chips are a limiting reagent. If we had more time and time in class to actually do this, we would have worked out this section 3. But I thought, baking is a really nice practical example to thinking about what a limiting reagent might do and limit you in how many times you can run your recipe through. So that's all I'm going to require for that. So that's the extent of the math that you're going to see on your test. I really hope that helps for a review. I know some of you probably didn't need this review because you've been really great at getting all your homework done and you really understood that well, but I think some of you probably really appreciated this video and just some extra practice to feel more confident going into your test. Good luck, you guys. Make sure you've worked this out and didn't just watch the video, but make sure you actually try the problem. So if you didn't do that, restart this video, do it actually working out the problems this time. Good luck on your test. Take it with good integrity and turn that in. And we just have a little bit of chapter 13 that we're going to dive into this week. It's very short. I kept it short since you also have a test this week. But this was a week where you had 3 block days to get some stuff done. So get that done. Let me know if you have questions. Show up to office hours. Bye.